Hello, it's Keith here, and this is lesson 12 of the Suck Hunt series of Z80 programming tutorials, and we're looking at the third and final part of the Amstrad CPC code. We're going to be going over the last part of the title screen and the main program loop. It's not so long today. We're going to go through it and just have a look. Okay, so where we got to last time was the title screen was showing, as it is indeed above. We just played the speech and now the music has started. So what we're doing next is we're processing the input from the keyboard and changing the settings accordingly, and of course starting the game. Now what we've got first here is the use of BC as a counter, and this will actually start the introduction again as a kind of a tracked mode as they did on the arcade games. So that counter will continue until it reaches 0, and that means we need to protect BC, as you can see here. And we're restoring it here, and that's so BC doesn't get lost, so that this can continue working. Now what we do next is we're testing a variety of key rows on the keyboard, and we're testing various keys for various functions that can be performed on the title screen. Now the title screen is of course 3D, and so we might need to switch our 3D glasses type, and we can do that if we press, I believe it's the C key here. Here we go, the C key will change the palette here, and if we press the 3 key, that will switch the 3D on or off. We can't change the depth because the title screen is a encoded 3D. The 3D is in the pixel data. We're not drawing the sections, and so we can't change the separation of them to increase and decrease the stereoscopic depth. So that's why we can only turn it on and off on the title screen. So if bit 6 is pressed, that is going to be the C key for color. Then we're running the change palette routine. If bit 1 is pressed, then that is the 3 key, and we're going to toggle the 3D mode. Usually we have 3 possible depths, but this time we only have 1, so we're just using 1 bit of depth 3D. We're toggling it on or off, and if the 3D has changed, we're going to redraw the title screen, but we're setting A to 0 because we don't want the speech to play again. So that's why we're doing that. Now, once we've checked those, the next thing we're checking is for the H key. The H key will start on level 128. It's to start in hard mode. We just skip the first 128 levels. We don't want the player to have to play all of those if they're feeling like a bit of a challenge. All we do is we set the accumulator to the level we want to start at, 128, and then we jump down here and we set the first level at the start. Now the final thing we do is we check the fire down data. Now this is set during the interrupt handler. The interrupt handler reads the joystick and the mouse, so the mouse is effectively a joystick, so they're both the same thing. And if it's been pressed, then we are going to continue down to here, otherwise we jump back to the top and we repeat. Okay, so we're starting a game, so we set the level number to whatever the level number should be, either 0 or 128 presumably. What we do next is we start the game song. So we've got a different song, so we use our change song routine. And then what we're doing is we are setting up the game data to the initial defaults for a new game. So we've got a template here, new game data, and then we transfer that to old POSIX, which is the first entry in the data definitions for the game level data. And we just set it all up, so that gets the game ready. Nice easy way of setting up all the variables as they should be. And again, some systems might be ROM based, and so they've got empty RAM, and we've got ROM with the settings we'd like that RAM to have. A system like CPC, the RAM is, all of the game data is RAM, so we don't always need to do that kind of thing, but it's still a nice way of doing things, to copy a template that never changes into RAM that we assume is empty. We then initialize the level with the enemies for that level. We repaint the screen, drawing everything for the first time, and we fade in and we start the level. So this is the main loop. We update the sound sequence. This is the Chibi Sound FX, which is my simple sound effect driver. It just uses Chibi Sound and just changes the byte of Chibi Sound over time to make a simple sound. I am working on a slightly more advanced Chibi tracker, which is going to play more proper music with 3 channels on multiple systems, hopefully all of them. So the Chibi Sound, the SFX driver is just a bridge, so to speak, for that. And then what we're doing next is we are reading in keys again, and the first thing we're going to do is we're going to check the P key. This is the pause. Now if pause isn't pressed, we're going to skip over the next bit. If pause is pressed, then we stop the music, we wait a while, and we're waiting a while just so that the key can be released. We then test the P key again because we press P again to unpause, and when P is pressed we wait again a little while, and then we just carry on. So a very simple pause routine there. we've got two ways of reloading our ammunition. Now, one is the right mouse button if we have one, but we might not have one. We might not have a second fire, so the other option is we can use the space key. I believe that's the space key there. We're just testing that. We run the reload magazine routine if that key is pressed. Now, what we're going to do next is we're going to check the cursor speed. So we are reading in a key again here, and it's C that changes cursor speed. There are 4 possible speeds, and this is important because the mouse, of course, depending on the speed of the mouse and how fast you move it, you might want different sensitivities, but also joystick control isn't ideal. Some people might like a nice smooth movement, a very fast movement. Some people might want a very slow one, just so they're comfortable. But, everyone needs different choices, so we have that. So that's how we can toggle between those. And what we do is we load in the current cursor move speed number. We then take 4 bits of that because it goes from 0 to 3. We update it, and then we convert that to an offset within cursor move speeds, which is a set of 4 possible words. We load in one of those words, and we update the new cursor move speed, which is used during the interrupt handler to update the X and Y axis. So that's how we do that. Now, what we're doing next is we are checking the palette key again. That's that P key once again for changing the 3D glasses type. We also check the 3D depth key. That's the 3 key. Again, we're using this time change 3D, which has 4 possible options: off, low, medium, and high. So that's how we do that. And that's the end of our key checking for now. So what we do next is we update the game ticks. Now, the game ticks update in an infinite loop, so these constantly go up. And what happens is different objects will respond to different ticks. So a fast object might update every 2 ticks. A slow object might update every 4. A very slow object might update once every 255 ticks. So that's how we make things like the moon move very slowly, but the bats move very fast, and they get faster as the game progresses. So the tick is a 16-bit value, and we can use various bits of that to make objects move at the speeds we want. What we're doing next is we're updating all of the objects. We've got our sprite data count, which is our count of objects, and our sprite array, which is the objects themselves. We run the animation routine for each, which will update them as required, and we then run update cursor after each one because we want the cursor to move nice and smoothly. Otherwise, a jerky cursor will make the game quite hard to play. If the cursor hasn't moved, this won't actually draw anything, but we at least want to check it quite regularly just to make sure we're done. And then we just move to the next sprite after we've done each one and repeat until we've done all of those sprites. So that's how we're doing that there. Now, what we're going to do next is we're going to handle the firing. Now, we have a weapon called the chibi gun, which is a machine gun. It's fully automatic. So this works slightly differently to the normal ones. What we do here is we're checking that world tick, and we're taking the bottom 4 bits. If they are not 0, then we aren't going to fire this time. If they are 0, we check if the fire is held. If the fire is held down, then maybe we want to use that chibi gun, but only if we have it selected. So we check the current gun, we see if it's number 3, which is the chibi gun, and if it is, we instigate the fire routine. So that's the special one that is just used for the chibi gun. We have also another reload routine here, this time using fire down 2. It's set by the interrupt handler on right mouse click, or fire 2 on the joystick. We use the reload magazine function to do that, and we clear fire down 2 once we've processed it. Finally, then, what we have is the fire down routine. This is for the left mouse button, the regular fire. We are just clearing that once we've processed it, and we run the fire bullet routine there just to handle the firing. And then finally we update the cursor once again. And then here we've got a loop which jumps all the way back up to here for the start of the main loop. Now, the rest of the code is in the multi-platform code, so that is actually basically the end of the game code. So basically the only reason this is platform specific is because of the old differences with reading the key presses and also the mouse. Apart from that, it could have all been multi-platform, but we would like it all to be multi-platform, but that's not really possible. So there we go. So that's the end of this, the final of the Amstrad CPC Suck Hunt series. But the suck will continue because we're going to be going on to the Spectrum next. I don't know if that made sense. Anyway, if you like what you see and you want me to see me make more little games and tutorials, you can buy a Suck Hunt t-shirt, which I'm wearing here from my Teespring store. You can also buy, possibly more usefully, my book, my Learn Multi-Platform Assembly with Chibi Akima's book. It covers Z86, 502, 68086 and ARM, as I'm sure you know by now, and you can buy it from Amazon. So if you want to support me and you want to see more and better games in the future, please do that, because I am planning to make more games in the future once I have that music tracker ported to all of my systems. Anyway, I hope you've enjoyed this today. Thanks for watching, and goodbye.